Alright, more factoring in this video. Last time we covered binomials. Now we're going to continue with trinomials, where we have expressions with three terms and, of course, higher degree exponents. Starting with a review, you should know how to factor this. All we do is find two numbers that add to 7 and multiply to 12, and that would be x plus 4 and 3. So this is x plus 4 times x plus 3. So here is how we add a new element to it with higher degree exponents. Now we no longer have x squareds plus x plus constants. We can have all different kinds of terms in these trinomials. Now this one's pretty basic. We're going to do the same thing we did in the last video. We have an x in all of these, so let's just start by factoring that out. And then we'll end up with the exact same thing that we just did right here. So we're just going to write x plus 4 times x plus 3. Make sure to carry over the x in front. And again, remember that all of these are separate terms, x plus 3, and x plus 4. They're all just being multiplied together. So there's no need for brackets or parentheses around this, as long as you can see that they're being multiplied together. Okay, now here we notice that we have an x squared or higher in all of them. So we want to factor out the highest term we can. So we're going to factor out an x squared from all of them. And now just factor what's in here. This is going to be multiplies to negative 12, so we know that we need one negative, one positive, and adding to negative 4. So we can use x minus 6 and x plus 2. Alright, now we have something here. We have 4 over x. So what is this doing here? How can we put this back into the form of x squared plus x plus constants? Well, you'll notice that if we're comparing to that form, all of the terms, the exponent's been reduced by 1. X squared to x to just a constant, which, by the way, is also x to the 0. X to the 0 is 1, so you could say there's an x to the 0 here. So we have x to the first, x to the 0, and 4 over x. Well, remember, dividing by x is the same as multiplying by x to the negative 1. So all we really have here is x to the first, to the 0, to the negative 1. So we're just going to multiply everything by x. In order to do that, we're factoring out 1 over x, or x to the negative 1. So now when we rewrite everything back in the standard form of a quadratic, which is what we've been doing, you'll see that we factored out an x to the negative 1 in order to increase the exponent by 1 in all of these terms. And of course, multiplying by 1 over x is the same as just dividing by x, since we could put all of this up in the numerator. Multiplying by 1 doesn't change anything. So we can write this as this factored over x. And now we just have to factor this. We're going to use the x here, since we have a coefficient other than 1 in front of the highest term here, x squared. Factors of 5 are 1 and 5. Factors of 4 are 1 and 4. We need to put the 4 here and the 1 there in order to multiply across and get 20 plus 1 equals 21, which is what we have here. So this is going to be x plus 4 times 5x plus 1. Okay, now let's move on to something where we have to do more than just factor out an x or something like that. If you look at this, now we have x to the fourth, x squared, and x to the 0 here. So now they're no longer 1 apart, which means we have to do something different. So it might help if we write out what this would be if it were a quadratic. It would look just like this. Now you'll notice that when we factor something like this, the terms always end up being something x plus number and then something x plus a number. So since we have x to the fourth here, we're going to have terms that look like this. So this would be some number x plus some number times some number x plus some number. What we're going to do here is the same thing, except all of these will change. The x's will change to x squared, and that's so that when we multiply them together, we're going to get back to the x to the fourth that we're starting with here, and you will see that that works out. So let's just factor this like normal, like a normal quadratic. We need factors of 9. Could be either 1 and 9 or 3 and 3. I'm just going to pick the correct ones here so that we can go a little faster. Actually, you know what? This is the correct ones. Yes. Yes, okay. There we go. That is the correct factorization. So factoring this, we would get x plus 2 times 9x plus 2. Now all we have to do is make these x's squared, and you'll see that this indeed works out. 9x to the fourth plus 2x squared plus 18x squared, that's the plus 20x squared, plus 4. So what we can see here is that because we multiply these two terms together with equal exponents, the exponent in either of these terms has to be half of the one that in the leading term. So that rule is going to help us when we have something like this. Now if you have x's in all of them, it's usually a good idea to factor the x as many x's as you can out of the problem. Because right now we have exponents of 7, 4, and 1. So if we factor out an x, we will have 6, 3, and 0. So now we do the same thing where we just factor this like normal. Let's see. There we go. That would be, yes, negative 29. Okay. Remember to keep the x in front. Now the only difference is that because we have x to the sixth here as a leading term, and also notice that this always has to be half of that, we're going to have 4x to the something minus 3, 3x to the something minus 5, and the something, the exponent here, is half of this. So it's going to be 3, and that's because we can see x cubed times x cubed will be x to the sixth, which is our leading term. So now with something like this, where we once again have this fraction here, it can be hard to see what we need to factor out. So it might be helpful to rewrite this part here as 7 times x to the negative 3. Instead of dividing by x to the positive 3, we multiply by x to the negative 3. And now you can see, maybe even write in a 1 here, this is 5, 1, negative 3. So they're 4 apart. And what we want to do, as always, is get it so that this is just a constant, or multiplying by x to the 0. So that means we have to raise all of these by 3, which means we factor out x to the negative 3. So factoring out a 1 over x cubed, and all of these exponents will go up by 3. Okay, so now we just factor this part over here. And we're going to have x half of this, x to the 4th minus 7 times 3x to the 4th minus 1 over this x cubed that's factored out. Okay, now let's look at one more type of trinomial factoring, where we have multiple variables. So you'll notice that the first term here has x squared, and the second term here has y squared. So what that means is that we're going to end up factoring this as something half of the two is 1. Think of it as a standard quadratic. If you ignore all of the y's, it is a standard quadratic. It's just 6x squared plus 17x plus 5. So we know we're going to have something x plus. Now the difference here is that we don't end with a constant. We end with a y squared. So instead of x's plus constant, we have x's plus y's. And then the same thing again. And if you look at this sort of theoretical example, we'll have x times x is x squared, then plus x times y, which is what we have here, and then plus y squareds. So now the only question, of course, is what are these numbers? And to do that, we once again just factor it like a standard quadratic, factors of 1 and 6. Actually, I believe that will not work. We will need 2 and 3 for this one. Yes, there we go. So instead of 2x plus 5, this is just 2x plus 5y. This will be 3x instead of plus 1. It'll be plus 1y. Okay, now we can do the same thing, but with all kinds of different exponent values. So again, ignore all of this stuff in the middle term, because that will just produce itself correctly if we make sure that the first and the last terms are matching. The only thing we need this middle term for is the coefficient for when we're actually doing this factoring x. So let's just factor it as if it were, say, treat it like a normal quadratic. It would be 3x squared plus x minus 2. So we would have this as the factorization. So now we just need to figure out what are the variables in these factored terms. Well, half x to the 4th, we take half of 4, so we're going to have x squared. And then in this, so that's x squared for the first term in each of these parentheses. And then half y to the 6th, half of the exponent, will have y cubed in the second piece in each of these parentheses. So we have x squared plus y cubed times x squared plus y cubed, and we just use these numbers to fill it in. So first we have 1x squared plus 1y cubed times 3x squared minus 2y cubed. And if you want to check your work, just make sure that the middle fills out correctly. We know we're going to get the correct terms on the outside, 3x to the 4th and negative 2y to the 6th, but just make sure. You'll see here we have x squared times negative 2y cubed plus y cubed times 3x squared. And that would be a bit complicated to check, or at least I'm not seeing it right now. So, well, if the outer terms always work correctly, then the middle ones will be correct as well. So you really don't have to worry about checking your work. Actually, let's save that problem for last. Let's do this one next. We're going to bring in 3 variables now. So the first thing you want to do is you'll notice the middle term has all 3 variables. You want to ignore that. Don't worry about that. Just focus on the outer 2 terms. And again, it's simple. We just follow the same rule. We take half of each of these exponents. So we're going to have the first piece of both of these parentheses will be x to the 6th z squared. And then the second piece will be y half of 2, just y. So we're going to have we're going to have numbers in front of x6z squared and numbers in front of y. Now we just look at the coefficients of these 3 original terms so that we can factor it. There we go. So we end up with 1 x to the 6th z squared plus 2 y times 5 x to the 6th z squared minus 8y. Alright, this last problem is going to be pretty challenging, I think. So what you want to do first here is notice that unlike in this problem where you had x's and z's in the first term and y's in the second term, here we have x's in the first term and the last term. And when you see it in the middle term as well, that means you have the same variable in every term. It can be factored out. So that's the first thing we want to do. But it's going to be tricky to factor with all these fractions here. So it'd be easiest if first thing we do is rewrite everything with negative exponents, since everything's all over the place right now. And while we're at it, we might also want to factor out a negative in front of for the whole expression, because we don't want to have that in front of the leading term when we eventually end up factoring. So this is going to be negative 7x to the negative 3 minus, or plus now, since we're switching all the signs, since we factored out the negative, plus 4x to the negative 1, y to the 5th, minus, we flip that sign, 36xy to the 10th. Okay, factor from here. What do we see? We have x to the negative 3, x to the negative 1, and just x to the first. So negative 3, negative 1, and 1 are all 2 apart, which is good because that means we will eventually end up factoring the x's. But the first thing we want to do is get rid of negative exponents. So to do that, we're going to get this one up to the highest non-negative, which would be 0. So we have to increase all of these by 3, which means we factor out of the whole thing an x to the negative 3, or 1 over x to the third. And if you'll notice, y is only in these last two terms, so we can't factor that out. So we're just factoring out an x to the negative 3. And make sure to bring down the negative sign in front of the whole thing. So now increasing all of the x exponents by 3, we end up with 7 plus 4x squared y to the 5th minus 36x to the 4th y to the 10th. And now we can factor with the coefficients 7, 4, and negative 36. So factors of 7, and now we got to find the right factors of 36. There we go. That's negative 14 plus 18 is positive 4. So now we have in front of the whole problem negative 1 over x cubed. Actually, doing what we did in the other problems, let's just put just the negative in front of the whole thing. And then put everything that we're factoring in the numerator, since it's being multiplied by just 1, all over x cubed. So what are the variables in these factored terms? Well, it's going to be, here we have nothing, so the first term is just constants. And then in the second part of the terms, it's going to be x squared y to the 5th. So here we just have 1 minus 2x squared y to the 5th times 7 plus 18x squared y to the 5th. Now there's just one more step we can do here, and that would be just to make this problem a little bit neater. It's already factored. What we can do is reverse the order of each of these terms so that the variables are at the front part of them. When you have a plus, we can switch the order without a problem. It doesn't affect anything. But when there's a minus, we need to factor out a negative from the whole thing, so that we'll have positive 2x squared y to the 5th minus 1. But notice, if we factor out a negative, meaning this whole thing is being multiplied by another negative, the negative times this negative here goes back to a positive. So it ends up being a lot cleaner because we get rid of this negative in front of the whole thing. And now we have all the variables in front on both terms. And this right here is the simplest we can get with this problem. Alright, that was a pretty hard factoring problem. You're normally not going to see anything that complicated. But we do have more factoring. In the next video, we're going to look at another method for factoring higher degree expressions. This time, if we have polynomials that are not binomials, trinomials, they have 4 or more terms.